Good afternoon, everyone. Thank you for attending our symposium presentation. We are the Nepal wheelchair team. This is the fourth year of our project. I'm Josh Hawley, the student project manager. I'm a mechanical engineering major and business minor. And our team is engineering a locally manufactured wheelchair for Nepal. So that's our purpose. And now I'd like to introduce two of my teammates.
Hello, everybody. My name is Caleb Mendoza. I'm a junior mechanical engineer major, and this is my second year on the team.
Hi, everyone. My name is Pauline Dutcha. I'm a senior engineering student, and this is also my second year on the team.
All right, thank you guys. So now we'll jump into a short introductory video so that you can get a little background on our project.
Have you ever wondered how people get from place to place in a mountainous country such as Nepal? It's a country you may have learned about as being the birthplace of the Buddha and the location of Mount Everest, the world's tallest mountain, in between China and India. It's home to remarkable cultural traditions, but the rugged terrain that encompasses this beauty brings along its own set of unique challenges. Nepali people with disabilities not only have the physical challenge of getting around, but also the cultural challenges as disability is viewed as a source of shame and dishonoring. They face a chronic lack of medical care, and for over 65 years, International Nepal Fellowship has been providing life-changing medical care. Unfortunately, due to the challenges of shipping medical equipment to Nepal, INF has struggled to meet the demand of their patients. One area that has been affected is their supply of wheelchairs. Currently, in the time it takes for wheelchairs to be delivered takes months and even years to arrive at INF hospital. Not only is the process timely, it also drastically impacts the cost of obtaining wheelchairs. This forces INF to reuse old or broken wheelchairs. To create a solution to this problem, INF partnered with a laboratory at Science University and the Nepal wheelchair team was established to meet this challenge.
This project has allowed us to engage in the engineering design process as we have created the design for the wheelchair. We have made sketches, ran testing using SolidWorks software, manufactured prototypes, and most importantly, gained feedback from our team and client. This project has also allowed us to integrate our work with other areas such as physical therapy. Our designs are made with the user experience in mind, and that has driven some of the key design changes. Our primary challenges for this project were making sure that we were using locally available materials, creating a design that could be manufactured with the tools available, and meeting the client's specifications. Overcoming these challenges would eliminate the need for INF to outsource these wheelchairs and allow them to provide more wheelchairs at a cheaper cost.
Keeping all this information in mind, the team set out to finalize the design, prototype it out of materials acquired in Nepal, and create documentation to aid the hospital in producing wheelchairs efficiently and accurately. The ultimate goal for this project is to produce a successful design that is easily manufacturable using the resources and materials available in Nepal. This design should function both in an indoor environment and outdoor mountainous terrain. With easy access to local resources and clear instruction provided through our manual, repairing and restoring defective wheelchairs will not pose much of a challenge to the local technicians. The Nepal wheelchair team accepted this challenge and has completed work to execute the design of a wheelchair that can meet this need. The team began in the fall of 2019 and researched the materials available and the metrics of a standard wheelchair, and has carried out functional and successful designs towards completing this project. Our mission is to develop and manufacturing processes that INF can use to manufacture wheelchairs locally for less time and less money than importing wheelchairs from abroad.
Have you ever wondered?
There we go. My bad. All right, so just a little preface here for our presentation. We won't be mainly talking about our initial designs as the fourth year of our project. Instead, we'd like to talk to you today about our accomplishments over the past year and all that we have accomplished. So I'll just jump into the presentation outline. So we're going to start off with some minor design changes that came about through the May 2022 site team trip to Nepal. That's last summer. Then the bearing solution and what we accomplished through that, the weight reduction data, and then fixtures, our welding and cutting fixtures. Then it's about our manufacturing manual and how we will use that moving forward to our site team trip in just a couple weeks. Okay, so this will play. This is a cool animation very cool animation Polly made. So here you have our wheel mount. There's a little glitch in the software, so it's not supposed to be moving like that, but you can see our push trim that was added. You can see our wheel lock that has a plate so that it can't escape. It can be adjusted to keep our tire in place. You can then see our footrests, which have a counterweight so that they can stay up, and we need to ensure that they're 90 degrees. And this is just a little overview of some of our designs so far that we've added compared to our initial. There you go. So now some design changes. Pauline will take it away.
So as Josh mentioned earlier, we were able to do a site team trip this past May, and we got a lot of feedback from our client that really informed these design changes just to help with the ergonomics and make sure that the user in the wheelchair is having the best experience. So I'll just run through them real quick. The first one was changing the seat angle, lowering that from 5 degrees to 3. The second one was about the seat design. So this is our previous design going into that site team trip. We were looking at implementing a fabric design, but after feedback, the client told us going back to just the plywood would be a lot easier to implement and replace. Next was increasing the width of the footrest. This is to make sure that the user in the wheelchair has enough space to rest their feet comfortably. So we increased that width to 150 millimeters. Next would be changing the design of our footrest. We realized during the manufacturing process that to keep the footrest at that straight 90-degree angle relied on specific tolerances. And so minor mistakes during the manufacturing process would make that footrest be slightly larger than 90 degrees. So we changed the design a little bit to get rid of the reliance on those specific tolerances. And then the last but not least, Josh already mentioned this, adding in that plate with the wheel lock, just to ensure that the user can't bring the wheel lock all the way back. That actually takes the handle out of the wheel lock assembly. So that plate just stops the range of motion, but still allows the user to fully brake the wheels. So I'll pass it back to Josh to talk about our bearing solution.
All right, thanks so much, Pauline. So now I'll jump into our bearing solution, which is another major goal that we accomplished this last year. Started off with brainstorming and design, a lot of different solutions we came up with. We came up with one that surpassed them all. So jump into that. When I'm referring to this bearing, I'm referring to the rear wheel mounts on there. So that keeps the axle bolts in with the wheels. So you can see here, the problem was that it wasn't available in Nepal. So our goal is to be locally manufacturable. And when we went to Nepal, in a couple of the site team trips, we ran into this problem where the bearings that we designed with our 16 millimeter axle bolt were not available there in their shops and stores. So you can see we need a 16 millimeter ID bearing and a 41 millimeter OD bearing, but the ones there were 17 millimeters ID and 42 millimeter OD, and then that fits with the axle bolt. And you can see in this picture here, kind of that the threaded bolt is rubbing against the inner side of the bearing, so that's also a disadvantage. But you can kind of see that in the solution here. That fixed. So the solution we came up with was a rounded nut design where you're going to grind the peaks of the nut down, and that's going to fit in the inner diameter of the bearings. So you're going to grind those flush, well, not fully flush, but enough so that it can fit in, so that it's kind of a press fit, but enough so that there's friction there. So for this, by doing this nut design with grinding it down, we had to increase the size of the bearings. So we increased the size of the bearings to 25 millimeter ID and 47 millimeter OD. So this and then increasing the size of the bearing plates as well, and the bolts that go along with that to tighten it down. So we can see that in some later assemblies. But the major advantage of this that fixed the last problem I was saying was that now that the nut can be threaded onto the axle bolt, and by doing this, there's not as much wear and rub, so it works a lot smoother. So now that this is our solution to the bearing problem. Now I'll pass it off to Caleb to talk about weight reduction.
So one of the biggest points of feedback from our last site team trip was to reduce enough weight from the wheelchair. We started with about roughly 40 kilograms, and they wanted us to reduce about 10 kilograms total from that wheelchair. So with this goal in mind, at the beginning of the year, the team got together and brainstormed various ideas as to how we could possibly reduce the weight from the wheelchair. And I'm going to walk us through the 2 techniques that we decided to carry out throughout this year. First weight reduction technique number 1 was, so we are using rectangular tubing from Nepali steel, which is material that is accessible locally in Nepal. And what I mean by reducing the wall thickness, as you can see in the overhead above me, the highlighted green area, more specifically in between the blue arrows, is the thickness that I'm talking about. We started initially with a thickness of 2.5 millimeters, and the team worked our way down to 1.5 millimeters. And I'll speak as to how that affected the weight reduction. So we ran 2 different tests on this on a computer analysis software. As you can see, first we ran a flat ground analysis test, and basically what this is it simulates a patient sitting down on the wheelchair, and it's their weight being distributed along the seat. We tested it with about 300 pounds, which is twice the average weight of an average Nepali citizen. And then we also did a front impact analysis, which basically simulates a patient also sitting on the wheelchair, but coming into contact, whether it be a wall or any obstacle that may come into the way. So after running these tests, we came up with different results As you can see in this table, we started out with 2.5 millimeter wall thickness, which was with our initial weight of 40 kilograms. And this gave us a maximum stress of 49 megapascals. And when we compare this to our yield stress, and just to quickly tell those who are not sure what yield stress is, it's just basically the maximum allowable stress that poses the worst case scenario for our material. When we combine that to the yield stress of the material, that gave us a safety factor of about 9. The team wanted to maintain a minimum safety factor of 2, so we were well above that. So we went ahead and reduced the wall thickness to 1.5 millimeters. And with doing this, we were able to take away roughly 4.3 kilograms of the wheelchair, 6 below our overall goal. And this gave us a maximum stress of roughly 76.9 megapascals, which then resulted into a safety factor of 6.2. So as you can see, yes, the safety factor did go down, but it still was well above our minimum of 2. So with this, the team still had to shave off a couple more kilos. So another technique that we had brainstormed and we implemented within this work cycle was identifying certain members of the frame from our last analysis tests and seeing which ones weren't significantly stressed and replacing them with angle iron. Angle iron is a material that is much lighter than the poly steel that we were using, but it also has a very high strength to weight ratio. So we went ahead and ran the same tests with this implementations. Before we go on to showing the test, these are just highlighted areas of the frame in which we identified as being not so significantly stressed. And these were the parts of the frame which we switched to angle iron. So as you can see here, I have the 2 tests side by side of a flat ground analysis. The first one being just reducing the wall thickness, and the second one being reducing the wall thickness and changing some of the tubing to angle iron. And the stress distribution is pretty similar, which we expected, but the maximum stress points were in different locations. But the most important part was the data that we got from this. So this table summarizes that test, which implemented the reduced wall thickness and the angle iron. And the team was able to take away 7.71 kilograms from the total 10 kilogram goal. And the team was content, even though we were 3 kilograms shy of our goal. And the most important part was our maximum stress identified was 111 megapascals. And comparing this to our yield stress, it gave us a safety factor of 4.34, which is more than double of our minimum safety factor. So the team was very happy that we were able to accomplish this goal while still maintaining the overall strength of the wheelchair. And I'll pass it back on to Josh so he can talk to you about the welding fixtures.
All right, thanks so much, Caleb. So yeah, and I'm going to talk about, just jump into some welding and cutting fixtures that we accomplished this last year. It was a major goal that we had. We started off with a lot of brainstorming and designing, and then came up with some really good solutions. We recently implemented those in the last couple of weeks and had those manufactured to take along with us actually on the site team trip. So that should be great. Yeah, so I'll just jump in here. You can see they really help us with, we're just really excited about our fixtures. They're going to really help us with just a lot of the welding and cutting procedures. So first off, with the welding, it causes a lot of heat, and that causes the angles to warp. So we don't really want that. We want the angles to, the perfect angle, so it's correct and stays in line. So we'll just jump in here. You can kind of see here on the wheelchair, that helps explain it. But here we have 2 pictures that show the groups of members that we selected over our design process to be included in our side and back fixtures, as well as another fixture that you'll get into a little later. So just to our simple design here, our concept is a parallel plate bracket. So this helps us to tighten the square tubing down in the fixtures correctly so that they can be in the right place. So this is just a simple, you weld a nut to it, make her stick. The main welding process in Nepal is stick. So we try to do that as much as we can. And then the bolt gets threaded into the nut, which then tightens the square tubing. So here we'll jump into the side fixture. So you can see it's actually a mirrored image here, because as you can see on the wheelchair, there's a left and right caster wheel. We redesigned it so that it can go left and right. And so we couldn't have just one side part. So through this, you can see you have to make a part on each side. And then there's table legs to help it keep off the ground so that you have an uneven surface. Because of all the uneven surface in the terrain, so we have to keep it off the ground. So there's some on the right picture, you can see a lot more like groups and stuff of our titles and groupings of our side fixture. So back fixture, very simple, similar design to the side fixture, except as Caleb mentioned, this is going to have angle iron implemented into it. So we had a lot of design to do, working with the screws and tightening them down so that the angle iron can also work. That helps with the weight reduction. And then the last fixture here I'll jump into is our crossbar fixture. So this was recently implemented in the last week or so. So when you have the two side parts out of the fixtures and the back part as well from the frame, you put them all together, and then to keep those in line, the correct distance so that there's no angles. So the distance is right. You put this crossbar fixture across, and this works in addition to the cross member, which is another bar in addition to the seat. So when those are all connected, our frame is perfectly in line. Now I'll pass it off to Pauline to talk more about our manufacturing manual.
Yeah, so this is the ending of this project, at least this edition of the project. So when we go on our next site team trip in May, a big deliverable for us is handing our client this manufacturing manual so they can have step-by-step instructions on how to build a wheelchair. It's very similar to the previous teams. We start off with just the materials list, the part list. This is an example of a table that explains the cutting procedure. So for the miter saw, these are the materials that would be cut by that, and then each piece is given a name. Next, we'll go into assembly. So this is an example of a table for the side fixture to explain the parts that go in and how to use the assembly. But the most important part are all the pictures. So we have pictures with each of the steps. Really, the written work is just supplementing to the pictures. But talking about moving forward, the team will be going on another site team trip this May to hopefully build the wheelchair again from scratch with our finalized manufacturing manual. Finally, we'd like to make acknowledgements to all the people who have made this project possible over the past 4 years. Our current members, our former members, of course, the Messiah staff in engineering, and our INF partners. So with a minute left, are there any questions? Yes, Professor Lockwood. Yes, the question was price of the wheelchair as part of the project was to make it as affordable as possible. So currently our price is going to be around 130 US dollars. Oh, so that is all the time we have for questions. Thank you very much.